This may also be a quick one. I don't suppose David's around.
Yeah.
Ah, okay.
So, all right, I guess we're moving on. We're gonna bump up the scrub repair with Sam here, and then we'll see where we go from there.
Okay, so this is also a duplicate of one from last CDS. We'll probably actually make progress this time. The main problem is that scrub and repair are not really in a good place right now. Repair particularly is awkward. If you issue a repair command on a PG, it pretty much just guesses for all the inconsistent objects what the correct answer is, and that's not really okay. So I think that the answer needs to be not less making the OSD smarter, because there's no way really to know which object is correct in the inconsistent case. Except if you have the hash on the object, which we generally do for RedHGW objects. In those cases, the OSD will guess correctly. But in the more general case with RBD, where we don't have an up-to-date hash, then we need to expose that information up to a user and get instructions. And there are a couple of pieces to this. One, the way scrub is structured makes it difficult to repair a single object. That needs to change. We need to restructure the way repair works so that scrub, when it's in repair mode, issues a repair operation on a single object, and then we can reuse that operation from a different part of the code wherever we implement the following interfaces. We need to be able to let the client query inconsistent PGs in a way that makes sense. Probably somewhere in Liberatos, a get inconsistent PGs method like I mentioned there. Similarly, we need to be able to get information about inconsistent objects in a PG. This needs to be pageable, and it can't cause a scrub when you cause it. So this means that scrub will need to write down its results into some form of temporary object so that we can query it. It's not necessary for this object to be persistent across the placement group, although we could choose to do that. I'm uncertain either way on that one. Basically, we could either make it a fully replicated hidden metadata object, or we could make it just a temporary object on the primary OSD that we have to rebuild after we go through peering. Not sure. We also need to allow a directed repair of an object via something like repair inconsistent object. The tricky part is the inconsistent info T, which needs to be able to give us all of the information we need to make a decision in repair inconsistent object. I think it might actually just be JSON. That will allow a certain amount of backwards compatibility. Yeah. There's some details with what to do with the case where we're issuing a repair based on inconsistent info T we got from a primary from a previous interval, but I think we just return E again and force the client to requery inconsistent PGs in that case. All in all, it's not enormously complicated. It's just a lot of work, and more importantly, Tethology tests need to be built to test all of this, or else the code will rot. All right, so people, I mean, if any of you have actually dealt with this stuff and have input or things you definitely know we need to be able to do, now would be a great time. Anyone?
So Sam, you were mentioning that you didn't want what you wanted basically to, for any case where we didn't have a checksum, for the user to have to use this kind of interface to query and decide which object is correct.
Up to a point, we could probably give it a repair with an intelligence threshold, maybe at the, 1 level. We let the OSD assume that anything that doesn't match the object info size is probably wrong, and maybe that's enough to repair it. So we might have some hierarchy of guesses we're willing to let it, or maybe at the very dumbest level, if it's missing its attributes, clearly that's corrupt.
Right.
But the real problem is that you get random little corruption bits in the middle because the disk did something stupid or the file system did something stupid.
Mm-hmm.
And in those cases, there's really no way to know which object is correct. You could vote.
Yeah, that seems to be
we don't even do yet. Huh? Yeah, so we probably should do that, but it's also the case that we would like to be able to present some form of, this is what's wrong with your cluster, am I allowed to fix it this way?
Mm-hmm.
That would be a little. And that's another thing. The inconsistent info T could simply tell you what it would do if you give it a generic repair. That would allow Calamari or what have you to put up a status update that sort of says, I would like to do this. Is this fine? It also lets us just bubble the information up to a layer that isn't the OSD and gives us a lot more
Right.
observability. So Calamari could do that.
Yeah, that makes sense.
It also means we don't need to rescrub the entire PG in order to repair objects. Although I guess we don't need to do that anyway, once we have a list of the inconsistent ones. So yeah, never mind.
You also mentioned persisting
Yeah,
the scrub results.
Oh, sorry.
You also mentioned persisting the scrub results. Would you be at all
Yeah.
worried about persisting those on the same disk that could be misbehaving?
Not enormously. It's a concern, but usually if the disk was that failed, then the OSD would simply have committed suicide and would be fine. So if this hastens us down that path, then I'm okay with that. That is, if the process of writing out the temporary object causes an EIO, then awesome.
Right.
Done and done.
It's quite easy to add a checksum to the scrub repair info too, so we can easily detect that kind of case. We're persisting the scrub data, read it back, and make sure that it's
If we actually choose to go through the normal IO path, then it would get a checksum for free because we tend to write it out in an append-only fashion.
right.
All right, I think that was quick.
Yeah, it was another quick one.